Oh, I guess I'm on. Okay, hi everybody. Hopefully you're in the right place. You're at Star Trek, right? Okay. Conference, and at the end of the night, we're going to watch Police Academy 7. That's the movie, right, Ryan? Oh, no, it's Mordecai starring Johnny Depp. Sorry, I was way off on that. Okay, so hopefully you guys are all here to learn a little bit about BDD and SpecFlow. My name is James Bender. I'm local to Columbus, so I see a lot of familiar faces. A lot of you guys have probably seen me and are sick of me, yet you're still sitting here, so that's on you. I am the Application Development Lead at ICC. Yay, ICC. And my email, my GitHub address, and I'm on Twitter, jamesbender.com. I love Twitter followers, so yay. So just a quick question. How many of you guys are doing TDD right now? And when I say TDD, I mean driven development. Oh, I saw some hands go down. How many of you guys are doing some form of automated unit testing? Okay, so that's good. It's more hands than I've seen the last couple times I've given this talk. Usually when I talk to people who are already doing TDD about this kind of thing, they kind of get this look on their face like, oh man, I just learned TDD and we're doing that and we're finally doing it right. And now you're going to make me do this other thing and I have to learn a new framework and a new way of doing things. So why do I care? So before I get into discussing what BDD is, I want to talk about some of the things, the benefits we realized from this. If you're doing TDD, you already have probably seen an uptick in your code quality, right? This means yes. Okay, good. So we want to go ahead and build on that. We've already gotten some good code quality, meaning that we have fewer defects probably. Now we want to really make sure we're aligning it with what the business is doing. And with TDD, that's easier, but there's still a gap we're finding. Your focus has already probably been better too. You've probably gotten into the habit of focusing on doing one thing at a time, doing it right, finishing, and moving on. That's another benefit of TDD. It tends to keep developers from multitasking and thrashing a lot. You probably reduce some of that code rust. And when I say code rust, what I mean is, when we've all seen it before, as systems grow and grow and grow, and we add more stuff, add more features, there are whole sections of code, sometimes lines, sometimes whole classes, that never, ever, ever get used. There's literally no execution path to that code. If you're doing TDD right, you should be eliminating this, because you should be testing your code with tests, and you should be letting those tests drive your code. And you should be using, hopefully, a code coverage tool to identify this code that's not being tested. At that point, you either write a test because you're missing a test, or you go get rid of that code. And hopefully, you've seen a reduction in bugs, especially those bugs that tend to prop up over and over again. You fix a bug, you close the ticket, and 3 weeks later, that bug suddenly comes back. And you're like, but I fixed that. And they're like, well, it's still broke. Go fix it again. And that happens over and over again. If you're doing TDD, hopefully you've seen a reduction in those kind of defects as well. So what I want to talk to you today is a little bit about what's next. How do we take what we've done with TDD, test-driven development, and build on that, and actually go to another level and make things a little bit better? And there's two ways to do that. And they're kind of similar, but they tend to have different names, although there are some very dogmatic people who will insist that these are not the same thing. Okay, fine, whatever. The first one is behavior-driven development, BDD, sometimes also referred to as business-driven development. And the other one is acceptance test-driven development, ATDD. Behavior or business-driven development is this idea that we're going to take the specifications and we're going to still create unit tests with them, but we're going to do them in a slightly different way, a way that really helps bring the business in a little bit closer. And acceptance test-driven development takes a little bit from a different point of view. With BDD, we're taking the specifications and then we're writing the tests. With ATDD, what we're doing is we're getting the specifications, we're writing a test plan, then we're using the test plan to write the test and then write the code. I've told that to people, and some people have accused me of, that's cheating. You're getting the answers to the test, and then you're just learning the answers. Well, yeah, duh, because that's what smart developers do. So there's really two key things here when we talk about BDD and ATDD. The first one is communication. Now, if you're doing Agile and you're doing TDD, hopefully that communication has been growing as you've been doing these things. Your communication with the business, understanding what they're doing, getting them to understand what you're doing. With BDD and ATDD, we're actually extending that communication a little bit farther. And we're going to use some tools to help us with that. But we really want to get to the point where the business analysts and the QA people are really almost partners with us in writing these tests and developing the code. The other thing we keep in mind when we do this is this idea of a specification. You guys have probably seen this before. You go off and do a discovery, which means you talk to a bunch of people about how this app is supposed to work. And then you generate a document that looks roughly like this. And then you put it on your desk. And it sits there, and you put coffee on it, and you put stuff on it, and you put little Avengers figures on it, and it just becomes, essentially morphs and becomes a piece of your cubicle furniture at that point. How helpful is that spec at that point when it's under 8 layers of junk? Probably not very much, right? Because I'm not moving that crap, I'll just guess. So we're going to kind of take these two things, this idea of communications and using our specifications to write our code, and we're going to use those to really enhance our practice of doing testing and writing code. Now the good news is we don't have a lot of slides, it's mostly code, so we're going to get into a demo pretty quickly. Before I get any further though, is there anybody here who's already kind of doing BDD and ATDD and you're just here kind of rubbernecking? That's cool if you are. Okay, good. Jim's kind of laughing, it means yes. Before you get started with this, two things. First of all, you are not going to be an expert in BDD or SpecFlow in the next 40 minutes. Good, nobody left. Okay. What my goal here is to just kind of show you what it's capable of doing and get you excited about it, to get you out and doing it and learning more. The subject of BDD and Gherkin, which is language I'm going to show you, is very deep, especially when you start getting into things outside of .NET like Ruby and JavaScript and things like that. The other thing you're going to find is there are people who are very dogmatic about this kind of thing. And when you get into it, you're going to hear a lot of stuff like this. Like, that's not how you do this. Well, the way you do this is the way that works best for you. I'm going to show you how I do it. If that doesn't work for you, don't do it that way. Do it a different way. You need to do what makes you productive, and that might be different from what Jim does and what Ryan does and what I do and what this guy does and that guy does. So whatever you take today, just kind of use it as an example, use it as a jumping off point, and kind of build your own way of doing things. This is just to kind of introduce you to the tools and the concepts and let you go from there. Cool? Yeah, James, that's cool. Great. Let's move on then. So we have a demo. Our business domain is tic-tac-toe. I like that because it's relatively easy and because I have a friend who works for Microsoft and he was writing a game and he couldn't figure out the algorithm to figure out who won a tic-tac-toe game. And I was thinking, dude, you work at Microsoft. How can you not figure this out? So I kind of like this because it ribs him a little bit whenever he sees me do this demo. He's not here today, unfortunately. But he's with us in spirit, hopefully. So we're going to write a library that's going to basically be an algorithm to determine the winner of a tic-tac-toe game. Our board is basically going to be, we're going to go simple. Our board's just going to be a multidimensional array of string. We'll have X's, O's. In the rare case of a tie, we'll just return back an S for stalemate. And if there's no winner, we'll return back an empty space. So we have a relatively simple set of specs. And everybody here understands how tic-tac-toe works, right? I do have to ask, because I have met some people who have never played it before. True story. So let's move into some code. Are there any questions so far on anything I've talked about yet? Okay. It's kind of hard to see all you guys because this is like, I talk to groups, but I've never talked to anybody with like, everybody's like up here and I have to like crane up like this. It's kind of strange. I was going to say you're the highest people I've ever talked to, but that could be taken in a very odd way. And I don't want to judge. I don't know you guys. It's none of my business. So what I have here is I have Visual Studio 2013. Now this is all going to be in .NET. If you're not a .NET developer, that's fine. The C# we're going to be writing is relatively trivial. You'll be able to figure it out. It's not too tough. If you're doing Ruby, if you're doing Java, if you're doing other JavaScript, whatever, there's BDD and Cucumber or Gherkin libraries to help you. So what the important thing to learn about today is kind of the workflow and also this Gherkin language I'm going to talk to you guys about. So don't get too, if you're not a .NET developer, don't get too hung up on that, okay? Now usually when I do this demo, I start completely greenfield, nothing here, nothing up my sleeves. But because I knew we weren't going to have Wi-Fi here, I kind of jumped ahead and did a few steps. First thing I did is I created a Visual Studio project, empty project called tic-tac-toe. Just nothing in it. Then I had to create a class library to hold our tests. Now, if you've been doing unit testing, you're probably used to creating these class libraries and calling something like myapp.test or myapp.unittest. Well, when you're doing BDD and using something like SpecFlow, we have kind of this conceptual shift. We're still writing tests, true, but the most important part of this process is the fact that these are specifications. We're taking that big giant stack of paper I showed you a few slides ago, and we're actually turning that into living, breathing code. So while our end result is we do get tests, we're going to think of this in terms of writing specifications, not specifically tests. So that's why I like to name my libraries whatever.spec or specs. The next thing I had to do, and this is where the Wi-Fi came into play, is I had to go out and I had to download some libraries. There's a library for BDD in .NET called SpecFlow, S-P-E-C-F-L-O-W. If you Google it, you should come up to it. It's made by a company called TechTalk. I had to install the NuGet package for that. So I did install package specflow.nunit. Now, SpecFlow provides some BDD functionality, but it still needs a unit test framework to work. My test framework of choice is NUnit. That's just what I like. If you like MS Test, XUnit, MBUnit, whatever else is out there. There are SpecFlow packages for those. Today we're going to use NUnit, but that's fine because we're really not going to be touching NUnit at all. The unit test framework almost becomes trivial at this point, so don't get too hung up on that either. So then we have our empty project. Now the first thing I need to do is I need to create what's called a feature file. Now the other thing I did forget to mention is I had to go out to that SpecFlow website and I had to install SpecFlow. If you're using Visual Studio 2010 or higher, you can go to External Tools, or I'm sorry, Updates and Extensions and Updates, and you'll install a SpecFlow update. And let's see if I can find it here and show it to you. Again, without the internet, it's kind of weird to show you guys where this stuff is. Where are you? SpecFlow, okay. So you'll go out and you'll install SpecFlow for Visual Studio, whatever you're using. That will kind of give you some of the updates. I just got this machine, and I had to do this demo a week ago, and I sort of forgot to install SpecFlow, and I couldn't figure out why my demo didn't work. And then finally I realized, oh yeah, I'm missing a big piece of software that makes all this happen. Are you raising your hand or are you signaling someone? Okay. All right, so my first step is I need to actually now write my specs. And the way I do that is I come into my class library here, and I right click, and I do add, new item. And when I installed SpecFlow, it gave me some extra items up here. I have a SpecFlow hooks for event bindings and a SpecFlow step definition. Those get a little advanced, so we're not going to talk about those today. If you want to learn more about those, the SpecFlow website has some good documentation and some good demos. They're useful for a lot of things, but not for what we're going to do today. What I care about is this SpecFlow feature file. So I'm going to go ahead and select that. Then I'm going to call this, we'll call this game engine, or we'll call this tic-tac-toe game engine dot feature. One thing I like to do when I'm naming anything, with classes, tests, whatever, I like to use long descriptive names. That way 6 months from now when it breaks, I'm not trying to figure out what specification 47 alpha-X is. It's just, oh, this should work. So it's a lot easier. So this is going to create a feature file for us. Hopefully, there we go. Okay, so this is creating a feature file in a language called Gherkin. Now, two things I want to point out about this. This is just a text file, okay? If I go in here to File Explorer, and I go into tic-tac-toe, and I go into my specs, I can see this feature file. If I pull this out a little bit, maybe I can. I can see this feature file right here, and if I click on it, I'm sorry, wrong one. If I click on it, it just comes up in TextPad. Now, it didn't carry the line returns, but whatever, you can figure this out. So the good thing about this is just a text file. There's nothing special in it. So what I can do is I can have a business analyst work with this file. And I'll talk a little bit about that later. But this is just a text file. Now, the other thing is you're going to do is you're going to look at this and realize that this is looks very much like what? How many of you guys are doing Agile? So it looks like a story card. Somebody said it. I'll assume someone said it. This looks a lot like a story card, right? It's the same language. It's the same kind of layout. I have a feature. I'm defining what I want this to do in order to blah as a somebody I'm going to do something. And then within that, we have scenarios. So we have our big feature. I wanted, in this case, it's kind of scaffolded some stuff out as an example. It looks like we're building a calculator. To avoid math mistakes, I want to build a calculator. That's kind of our big overarching feature. It's almost like an epic. And then underneath it, we have different scenarios. Like I want to add 2 numbers. Maybe there's another scenario where I want to add 3 numbers, do division, whatever. But this is something that looks like a story card. So your business analyst should be able to read it, understand it, or even write it. Correct? Yes, right. If you have, for those of you shaking your heads, no, I want to meet your business analysts. Because I think I'd have a lot of fun with that. Because I'm not a very nice person. Anyway. So this is basically, how many of you guys have heard of Cucumber or Gherkin? So Cucumber is a tool for writing these, good, a lot of hands. Cucumber is a tool for writing these tests, for those of you who didn't raise your hand, and it uses a language called Gherkin. And it's probably the easiest programming language you're ever going to learn because it really only consists of 4 phrases or 4 commands. Given, when, then. And as you can see here, we have an and is there, well, if I want to kind of stack things. Given, I have an existing starting condition. When I do something, then my state should look like this. That's it. That is the extent of the language. And again, if you guys have been doing Agile, you're writing story cards, you should already kind of have a lot of stuff that looks like this in your backlog. So this makes it very easy for business analysts to participate with you in the application development process. Now, we're not actually writing a calculator today. We're going to write this tic-tac-toe engine. So I'm going to change my feature a little bit in order to determine the outcome of a tic-tac-toe game as the tic-tac-toe game engine. I want to evaluate the board to see what happened. This is probably not the most formal feature you've ever seen, but that's okay. We're not going to tell anybody, right? Good. I can tag my scenarios. That's what this thing is on line 6. We're not actually going to talk about that today, so I'm going to get rid of that. So now I have my big overarching feature, right? I want to figure out who won this tic-tac-toe game. So I have a bunch of different scenarios I can come up with within that space. And we're going to do some pair programming later. I'll go ahead and do the first one on my own. So my first scenario I'm going to say is when I have an empty board, then there should be no winner. Now in this case, my scenario name is going to match my Gherkin pretty closely. That's not always the case. A lot of times the scenario name is kind of used as a truncated version of all the steps. But this is a pretty simple scenario, so we're okay here. So I'm going to kind of erase what I've got. And we're going to say, given I have a tic-tac-toe board and the board is empty, when I determine the winner or determine the outcome, then the result should be a stalemate. So you notice it's case sensitive too. It didn't like that I used lowercase w with when. Frankly, I don't. That's kind of kludgy to me, but whatever. I didn't write the framework, and I'm too lazy to fix it. So there we go. So there we go. We have our scenario. Makes sense, right? We could see mapping a business thing to this, right? Okay, you guys are awake, right? You got enough sugar and caffeine. Okay, good. Have to ask sometimes for these early morning ones. So that's great. We have our Gherkin, or our cucumber rather, or, well, our Gherkin, which defines our steps. Now we need to turn that into an executable test. SpecFlow has this thing we can do. We right-click here, and we can hit this button that says Generate Step Definitions. Okay? So we click on that, and we get this nice little dialog box. And it's gone through, and it's looked at all of our Gherkin in the feature file, and it's found anything that it couldn't find an executable test step for. And it's listed it in here. And by default, we want to go ahead and create all of these, and that's fine. Down here, oops. Down here, it's going to say, suggest a class name for us. Again, that's fine as well. And we're going to hit this generate button. Now, we're going to talk, there's copy methods to clipboard button. We're going to talk about that in a few minutes. But for now, we're going to go ahead and hit generate. It's going to pop up this other dialog saying, do you want to create this file? We do. And if I come back here to Solution Explorer, I now have a C# file with my test steps. And I always get that because that's fun. We'll go ahead and format it again. So, quick question. What does this look like to you, some of you guys? What? Unit test. Looks a lot like a unit test. It's a little different, right? It's not quite a unit test, but it looks really similar to a unit test. What we did with SpecFlow is we went to our Gherkin, and we basically realized we have all these steps. We need to create code for them. So we generated these things called test steps. And what we have is we have a method for each step. And we can kind of see here with these attributes. Actually, I screwed up. Oh, no, I didn't. Sorry, never mind. We have all these attributes. And they fall into one of three categories, given, when, or then. That helps SpecFlow understand what order to run these in and what their job is. And in that attribute, we have the name of our Gherkin. Oops, sorry, our Gherkin line, our line of Gherkin. So what SpecFlow is going to do is it's going to map these steps I've outlined here over into these test steps. Okay? Now, I can run these tests. I'm using ReSharper today, but if you're using NUnit test run or MS test, whatever, that'll work as well. I have ReSharper, so that's what I'm going to use. We're going to go ahead and run these tests. And what we're going to see is it's going to run, hopefully. It's a little engine that could. There we go. And, OK. So we got inconclusive. And if we zoom in here on the results, what we see is it's listed off. Oh, that's high. It's listed off all of our steps. It said, I found these steps in this feature that you want to test. And it goes through them step by step. Now, it didn't get very far, obviously, because it got to this first one and said, pending on this method. What does that mean? Well, if we go back and look, what it means is we're returning a pending status, meaning we haven't written anything for this. So what we need to do is we need to have a board. So the first thing I'm going to do is I'm going to declare a board. And I'm skipping a couple steps here. I'll explain that in a minute. Oop, not string compare. That's not what I want. There we go. And why don't you like that? Well, I'm doing an array, though. Maybe I need to do this. Oh, there we go. OK, it just wanted the numbers. OK. So I declared a string array. Now, you guys who are doing TDD are looking at this saying, well, wait a minute, you're kind of forecasting a little bit, right? Because you're assuming you need this as an instance variable. And when you write your first test, everything's self-contained and blah, 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 blah. And you're not wrong. And if you're doing TDD, yes, that's how you should do it. But in this case, A, we're pressed for time, so I'm not going to do that. And B, I already know kind of that my next step is that I have to declare this board as empty. So I know I'm going to need this in another method anyway. So what I'm going to go ahead and do is just create that as an instance variable, mostly in the interest of time for you guys, so I don't waste your time. And there we have it. So now if we go back and we run our tests again, we got a little bit farther. We can see now that that first step is done. But now it's stalled on the next step because it's OK, well, we still don't have that set up. So let's go ahead and implement some more of this stuff here. So the next thing we need to do is we need to say that that board is empty. So I'm going to say board equals. I'm going to do a little bit of cheating with copy and paste. I'm usually not a huge fan of this. But again, we're all friends here, and no one's going to rat me out. So I'm totally cool with that. And why did it not like that? Oh, maybe I need to do this. There we go. Oh. OK, there we go. So now we've got that next step. We created our board, and we created it as empty. Now, I usually get asked at this point, why didn't you just do all that in one step? Well, sometimes I want to keep these tests small and composable. That way I can do a lot of what's called reuse. Now, for those of you guys doing TDD, this is a concept you're not going to be familiar with in tests, because usually we write a unit test, and that unit test is, I've always preached it should be isolated and independent, and and that's, again, correct for unit testing. But you're going to see here when we do our next scenario, we want to make these smaller and more composable because we can actually start combining these into larger tests. So that's why I like to keep those two separate. Now I want to determine the outcome. So I need to capture a result. And we're going to need something called a game engine to do this. So we're going to do game engine, get winner. And we're going to pass in our board. Now, this is where, for those of you doing TDD, it's starting to look a little familiar, right? Well, OK, I already see a problem here. You have this game engine declared, but you don't have it created yet. This is getting to that TDD. We're letting these tests drive our development. We didn't need a game engine up till now, but now we do. So we'll go ahead and create one. So I'm going to go ahead and create a new class library. And there are some people who will say you should do this in the same library as your test until you need this in your actual production code. And that's kind of dogmatic, and I understand where they're coming from. Personally, from a pragmatic point of view, I rather keep it in a separate library, because if I'm doing the requirement and it's already been scheduled, then that probably needs to get moved anyway, and I'd rather just create it where it's going to live and just leave it and not have to worry about it. So that's what I'm doing, and you're free to disagree with me if you like. Probably not going to change my mind, but stranger things have happened. OK, that's weird. Why is it saying you're in use? Let's try this again. Let's go this way. OK. Okay, we're going to cheat then. We're going to just create a new class. Sometimes Dropbox doesn't realize that it's in my way, and it tends to do things I don't like. So we're going to do class, game engine, done. Okay, good. Need to say it's public. Now we come back to our steps here. And now I'm going to go ahead and do something else here that normally I wouldn't advocate, but again, in the interest of time, we're going to go ahead and just do it this way. I'm going to do private game engine equals new game engine. No, that's not what I wanted. Thank you, though. Oh, private game engine. Sorry. Visual Studio is so helpful sometimes, isn't it? I just want to hug it and hug it and hug it till it almost can't breathe anymore. I'm helping you, I'm helping you. Let's do this. There we go. Okay, now hopefully ReSharper is going to cooperate with us today. And, oh, it didn't. Okay, we're going to have to do this by hand. Normally ReSharper does all this for me, but it's not cooperating today, so we're going to do it by hand, like they used to do in old times when things were black and white, and we all rode in horseless carriages. There we go, okay. Game engine, and we don't need this anymore. Okay, so I cheated and the universe punished me. What are you going to do? Okay, so now we need to find this get winner. We're going to have this just return a string. It's going to take a string array of board. And for now, we're just going to return an empty string. Let's come back to our steps. Still says, so this happened before for me. It'll still say it's red even though I bet you it compiles. Let's build it and make sure. Yeah, Visual Studio. Hey, Microsoft, before you put out 2015, maybe get 2013 working right. I don't know. It's just me. Okay. In spite of the fact that this is red, this builds, so we're good. So let's run this again just to make sure. And we're getting closer. We have one last step that we need to implement, and that's just checking our results. So that's easy. What we're going to do is come back to our code here, and we're going to use the same old NUnit assert static class we've known and loved. And check it here. Now when we run this guy, we're going to see it passed. We executed all of our steps, and they all executed correctly. So this is kind of cool because I've broken it down into smaller things. And normally when I have a unit test, I try to keep them small and atomic, but sometimes they can get kind of big. But this way, if something fails, I know right away where it failed. I mean, I have it all listed out as my specs, right? So when one of those specs fails, I know really, really where to look. I mean, with TDD, I know kind of where to look, but now I can almost target it in like a laser, almost to the exact line of code. So that's kind of cool. I like that. Now, here's another cool feature, which I kind of talked about, the reuse idea. This is something that's going to kind of blow some of you TDD guys away. What's another scenario we can do here? Say all top rows are X's and X wins, right? That's the tic-tac-toe thing. Sure? Okay. So we'll do scenario when X is in all the top row, then X wins. Reasonable? Okay. So given, first thing obviously is I need a board. So given, I have a tic-tac-toe board. Now, here's something interesting. I had Intellisense pop up here. And what it's saying is, so you've created this library. You already have some givens, and you have these two right here. Do you want to reuse one of these? Well, yes. I don't want to reinvent the wheel if I don't have to. So we're going to go ahead and use our existing, I have a board step. And the top row, now I get the Intellisense again, but in this case, none of those really match, so I need to write one. the top row is all x. Notice here I'm putting x in quotation marks. We'll see why in a minute. When, and again, I get my Intellisense, I determine the outcome. Yeah, I'll go ahead and reuse that. Why not? Then the result is x is the winner. So I don't know if it really shows up on this projector. Oh, it does really good. You'll notice 2 of those lines are purple and 2 of them are black. What that's telling me is SpecFlow found definitions for 2 of my 4 clauses. And it's allowing me to reuse them. This is, again, why I try to keep those things separate, why I try to keep them small, why I try to keep them modular. Because this just eliminated half the work I have to do, right? Yes, it did. Yeah. But now, sorry? So he's asking me, do I give my BA visual for the autocomplete? Hold that thought. We'll come back to that in a minute. So what I need to do, though, is I need to create 2 more step definitions here. Now, this is where we get into that thing I talked about before. We're going to right-click, and we're going to do Generate Step Definitions. And it found the ones that weren't already in the test file. It only found 2. Now, here's where a lot of people make a mistake early on and end up kicking themselves, especially when they have hundreds and hundreds of test steps. If I hit the Generate file right now, who wants to guess what's going to happen? It's going to wipe the old ones out. It's going to create a brand new file with just my 2 new test steps, and the 4 I have now are just going to go gone. So I don't want to do that, obviously, unless I have everything in source control, which I don't. And even then, don't do that. I want to do copy methods to clipboard. So I'll click that. Now they're all on the clipboard. I come back to my test steps file, and we'll go ahead and put these at the bottom, because why not? And we have our 2 new test steps. So we have a given and we have a then because we need new ones. Now, looking at these, they look very similar to the ones we had before, right, with our clauses in the attributes. But in this case, and I don't have a laser pointer, unfortunately, you have those kind of weird things with the bunch of quotation marks and the asterisks. Who knows what those are? Regular expressions. I wish I had a prize to give you, but I don't. Actually, I don't. Whatever. Sorry? Now I have 2 problems. I have a regular expression. I don't have a prize for this man. Bump. So yes, what this is letting me do is since I put that value of x in a quotation mark, SpecFlow said, OK, you're putting this in quotation marks, so I'm guessing you're going to want to vary that at some point. You want to pass me something different. So what it's doing is it's creating a regular expression, and obviously this asterisk is pretty much you can pass anything, whatever, don't care. But it's assuming I'm coming in as a string. I could change it if I wanted to here, but I don't. A string is fine for me. It's going to map to this argument p0. So what I can do here is I can just kind of use that value to fill out the rest of my scenario here. We'll do board 0, 0 equals p0. And we'll do the other 2 cells. So right now we have x or whatever, because we don't care at this point. We're just getting a value all across the top of our board. The next step is we need to verify that we have a winner. In this case, I already have my then happening before, right? We already have that happening on line 31 here. We don't need to rewrite that. I just need to assert that it's the same thing. So assert are equal p0 and result. So we'll save that. We'll go back to our feature. And we all have, and we don't have any purple text left, so that means all of our steps have been implemented. So let's go ahead and run this and see what happens. Well, the test it ran passed, but that doesn't really do what I want. We want to run all the tests. And we got a failing test. Oh! If we click on this, we can see, we get a little more information. We can see that all of our steps happened, but we were expecting an X, we got back an empty space. So this looks a lot like a unit test failing, right? Oops. I can scroll down here and I can see my StackFlow. I can see here all the steps in my Gherkin where, yeah, this worked, this worked, this worked. This is where we hit the snag. So that, again, helps me figure out where my problem is and fix it faster. So we'll go ahead and duck back down here, go to our game engine. Now, one of the things I talk about in my ATDD talk is when I write a test and I go to write the code, what do I want to do? I want to write the simplest thing that might work. In this case, that is, and I know I should probably ask and see what you guys come up with, but Is that the simplest thing that might work? Yes. Well, let's run the test and find out. Yes, it worked. So here's the thing that also kind of throws off a lot of people with TDD and BDD. If these were the only two specs we had for our game engine, we could ship it right now. It'd be the worst tic-tac-toe game ever. But I mean, let's face it, on Windows Phone Store, it'd still get 3 stars. But we could ship this right now, and that's not how tic-tac-toe works. No, you're right, it's not. But as developers, we need to let the business decide what done means. We need to stop trying to figure that out on our own and let the business dictate it. With the ability to create these feature files, I can make them do that. They can tell me what done means. I don't have to guess anymore. I don't have to do what's called gold plating. I don't have to try and outthink the business. I let them decide what they want it to look like and how it should look when it's done. Okay, we're doing good on time, so 2 more things I want to show you guys real quick. I mentioned that this uses the regular expression, so let's go ahead and we'll do some copy paste here just in the interest of time. Come back over here. Now let's say we want to do this same test but with O, because there are 2 sides to tic-tac-toe. Oops. We'll change all this, change all this. Now one of the things you're noticing is it's not telling me I need any more step definitions, right? So I've created this whole other scenario. Completely different, nothing like the first one, right? Totally not even close. So we should have 3 tests now, right? If I run these, now who thinks these tests are going to pass? Who is totally apathetic and is just waiting for the next session? One guy say, I kind of, to be honest, whatever. All right, well, let's run these and find out. So we have our 3 tests. It's not running the new one because why would it? Let's run them all this time. Thank you. So yeah, we got a whole other feature or scenario we were able to test, and how much code did I write to add that scenario? Exactly none. That's kind of big, because what happens is as you're building more complex systems that actually do more than tic-tac-toe, you start building these collections of clauses in this library. And as your BIs start coming up with new different scenarios, what ends up happening is they start using a lot of these pre-existing steps. So you get to a point where your BAs can start adding more tests, adding more scenarios, and the amount of code you have to write starts going down dramatically to the point where they can be adding new scenarios and you don't even know it until something breaks. Which actually is a good thing, because it means it's something you missed that needs to be taken care of. So that's huge, because they can test to their heart's content, and you're fine with it. Occasionally you have to implement a step, but that likelihood starts to go down after a while. So one last thing I want to show you, and I don't think we're going to get all the way through this part, but if I had to do a tic-tac-toe demo or game like this, and I had to write every scenario like this, it'd get kind of tedious after a while, wouldn't it? I have to say, well, when X is here and O is here and this is what, I'd kill myself. I don't want to do this anymore. That gets kind of boring. Imagine if a BA had to do this with a credit card application form that has 50 fields on it, and had to do all those variants of all that particular data that could be in those 50 fields. That would be a nightmare, right? They wouldn't want to do that. Well, SpecFlow and Cucumber give us the ability to create what are called tables. And what that looks like is, well, we're at a scenario and I'll show you. When I have a table that looks, when I have a board that looks like this. Given I have a board, and we have our Intellisense there, and the board looks like this. Now I can use the pipe symbol to create columns. I'm calling these column 1, 2, and 3, because why not? And now basically I can just feed data in here. So let's say we have an X here, we have an O here, and say this one's blank, and then say we have the next line, we have an O, we have an X, then we have another O, and down here we have a space, a space, a space, and another X. So what does that table look like? A tic-tac-toe board. Yes, it looks exactly like a tic-tac-toe board. This is helpful because now I can, first of all, I'm not typing over and over and over and doing all this tedious stuff. I have a visual representation of what that board looks like. That's great because it's easier to do, and I don't have to, I don't have to worry about missing a condition. I can look at this now and see every permutation of the board I need to have and make sure it's there visual. I'm not reading oogles and oogles and oogles of text, right? Again, think back to that idea of a credit card application form where a user has 50 fields and I need to test every permutation of every possible thing that could happen. This is going to make that a lot easier for them because it also looks like what popular BA tool? Jim, you're not allowed to answer. Begins with an E. Excel, yes. BAs love Excel, I think more than Word. And that's great because they're productive in it. They can do some great things with it. This looks a lot like Excel. So they can take their Excel data and put it in this table, and they can rock on. Now, if I finish this test up, oops. Then, when I determine the result, or determine the outcome, then the result should be X is the winner. It did mess up my format. I don't care. I'm not going to change it. Now we got to go ahead and generate these test steps. Generate step definitions. We only have the one this time. We'll copy it to the clipboard. And that's what we get. Now we get back this structure called a table. And all that table essentially is, there's some wrappers around it, but all essentially is a multidimensional array. We just column, row, get our data out. And we can basically loop through that, iterate however we want. I'm not going to finish implementing that now because we are running a tiny bit short on time, and I want to get to this gentleman's question. But does anybody have any questions about what you've seen so far? Probably not. I mean, I don't mean to be glib, but it's been like 3 years, and they haven't done it yet. So he asked, are they going to fix the generate deal? And that's the thing we kind of alluded to before, where first time I create my definitions, I hit generate, it creates the file. Second time, it wipes out the file. He asked if they're going to fix that. It's been 3.5 years. I'm not expecting it at this point. Huh? Yeah, it is. I think it's open source, so feel free to go out and fork their repository and implement it. So it overlays the file. It nukes and paves. No, well, it would bring it back, but your stuff would no. Well, no, actually, because it would delete the file, then recreate it. So, right. Yes.
Can you turn that first step into like a background step because you're using it for every scenario?
So the question is, can I turn that first step into a background step? In SpecFlow, that feature is on the board, but I don't think they've implemented it yet. I know in other implementations, like with Ruby and I think in Java, you can do that. Basically, what he's asking is, since I do that I have a tic-tac-toe board every time, can I essentially turn that into almost like a constructor for my test? And the answer is, in everything but .NET, yes. .NET, it's supposedly coming, so keep your eyes open. We'll see what happens. Okay, one thing this gentleman had asked me is, when I give this to a BA and have them do this and write my test, do I give them Visual Studio? That depends. It depends on a lot of things. Is my BA pretty technical? Do I trust them with Visual Studio? Do I have a license to give them Visual Studio? And if I do, if all three of those are yes, then I really have no problem putting Visual Studio on a BA's machine. For those who don't, or if any of those answers are no, then I use another solution. And usually the solution I have found best is to give them their text editor of choice, be it Notepad++ or Sublime, or I've never met a BA who used Vim, but there might be one out there, I don't know. Most of those have some sort of Intellisense plugin where they can realize that this is a Gherkin file, scrape it, and give you the Intellisense for these things. So I will give them that. And then what I'll also do is, because we want these in version control, there's a version of Visual Studio, I forget what it's called, but it's basically just the shell with the version control explorer in it. I'll give them that to do their check-ins and checkouts, or if it's git commits and pushes. That kind of hides it behind the scenes from them, so they don't have to worry about it. We get the version control, they get the Intellisense, and we get our test written by not us. So, the people who make SpecFlow do sell an Excel extension to plug into Excel and get these tests and do this thing. I have yet to ever see that work, so don't spend the $400 on it. It has the benefit of being really expensive and not working. So, great sales pitch. Any other questions before we get back to the slides? Okay. I don't need the warning anymore, by the way. I do need to know where my slides went. There they are. Okay. So some supported concepts. For those of you who are already doing TDD, you might be familiar with these. The first one is mocking. Usually, when we're writing these applications, we're not fortunate enough to be writing a tic-tac-toe thing, which is pretty isolated. We didn't have any external dependencies. There's no database, no logging, no web server. I'm guessing you guys are going to run into that issue at some point. When I'm writing these tests, I don't want to test those external things. I don't want to test the database. I don't want to test the things that are horizontal or vertical in that architecture. I just want to test the things that are in that block of code, that method, that class, whatever. What mocking does, it allows me to create stand-ins for things like a database and a service and my horizontal architecture. So I'm not actually testing those. I'm creating mock-ups or dummies that just return canned results. So that has the benefit of doing a couple things. First of all, it helps me isolate my test to the part I care about, which is between those two curly braces. It gives me consistent canned results back. If all of us over here are on a team and we all have a test that hits the same database row on the same database table and changes it, and we all run our test at the same time, what's going to happen? Most of us are going to be really unhappy, yes. One person might be okay. The rest of us are going to be really upset because we're stepping all over each other's data. And not only that, databases are slow, so it's going to take a long time for us to realize we're unhappy. Database transactions are time-consuming. I'm not just picking on databases, but they're the easiest one right now. Using a mock gives me that isolation and gives me the speed. It may make a difference between taking an hour to run my tests and taking 20 seconds. I've worked on projects that have 2,000 unit tests. With mocking, we can get those running at about 40 seconds on a slow machine. We have integration tests. We only had 50 integration tests. Those took 2.5 hours. We only ran those at night. So mocking is definitely important. Another concept, one that really makes mocking possible, is this concept of dependency injection. Now, those of you, especially in the Microsoft world, who came up reading the Microsoft books and looking at their demos on their website, are used to seeing things like create a class and do private my database equals new database connection, right? Because that's the way Microsoft told us to do it. That's wrong. The problem when you do that is you create what's called a static dependency. I don't want to depend on the I want to depend on the concrete implementations of that database. I want to depend on an abstraction of that database. And I don't want to receive the concrete implementation until I'm ready to run. That way, if I need to change that at runtime, I can swap in whatever I want. As long as it supports that abstraction, I can put whatever I want in there. It could be Oracle, SQL Server, Mongo, file system, web service, doesn't matter. I don't care about the concrete implementation until runtime. Dependency injection is a method that allows you to inject those dependencies at runtime. Sometimes it's also referred to as inversion of control. There's big, long white papers where people will fight over what the difference between those two phrases is. For us, for the most part, they're pretty much interchangeable. None of us are writing computer science white papers, I'm guessing. Well, Jim maybe, I don't know. Jim just reads them. If you ever see Martin Fowler somewhere, he will argue with you at length about why they're different. You know, don't care. For me, they're the same thing. Essentially, what this practice does is it allows you to inject those dependencies in your constructor. There are frameworks out there to help you do that. These are both easily hour-long topics, so we're not going to cover them today. Just be aware that they're out there, and if you're going to follow or start getting into this, these are definitely things you should look into. So lastly, I'm guessing a lot of you guys aren't doing this right now, but you're going to get really excited because, hey, I saw this awesome presentation at StirTrek, but then I saw this other one about TDD or BDD. And I kind of want to do that too. And you're going to go back to your boss on Monday. You're going to say, we should do all this stuff. And your boss is going to be like, yeah, no. Bosses are human beings, not nerds. They don't think like us. There's two things that most managers really concerned about. Who wants to take a guess what they are? Money. Well, money and money. Well, not wrong. Time and money. Those are the two biggest things managers worry about. Are we going to make it on or under budget? Are we going to make it on time? That's what their world revolves around. So I want to show you two charts that kind of help you make the case for this. This is one you've probably seen before, or some variation of. This is kind of a modifier of the cost of fixing a defect based on when you find it. And the modifier all down here at the end, if you can't read it, requirements phase, 1 time. Construction, 5 times. Post-release, 100 times. So to keep the math simple, let's say it costs $100 to fix a defect. If we find it in requirements, it costs $100 to fix that defect. No big deal, probably budgeted for, part of life, move on. If we find it in development or construction, again, $500, probably part of the budget anyway. No big deal, fix it, move on. If it makes it to post-release, that same defect now costs $10,000. And all that really accounts for is person hours to find it, fix it, test it, redeploy it. It doesn't count things like lost sales, angry customers, violated SLA, potential security exposure, any of that other stuff. Now, I'm not saying that if you do this, you'll never have defects down here. But what I am saying is, and it's been proven out, most of the defects will be pushed down to this part of this graph. You're always going to potentially have something sneak through because we're humans. We can't think of everything everybody's going to do. But we'll greatly decrease the cost of maintaining this app over its lifespan by moving those defects down to this end. So that addresses the money aspect of it. The next one is time. And this graph takes a little more explanation. They took several teams at IBM and Microsoft. And when I say team, it's not like our teams where we have maybe a dozen people. This is like teams of 2,000 developers. And they broke those up into sub-teams. And you can see the products down here. For IBM, it was drivers. For Microsoft, it was Windows, MSN, Visual Studio. And half of those sub-teams did TDD and half of them did not. And they did some kind of normalization process for features, figuring complexity and everything else, to figure out how long each feature should take and how many defects that feature should have, to just kind of get apples to apples comparison. What they found is people who were doing TDD, like in the case of Windows, it did take 35% longer to develop each feature. That makes sense. You're writing tests up front. If you're new to this, there's a learning curve. Makes sense. It's going to take a little bit longer up front. But what they found was in cases of defects, like Visual Studio, they had 9% of the defects they were expected to have compared to the other teams. To me, that's huge. I mean, it means if I write an app and I'm expecting to have 10 defects, maybe I'll have 1. Have you ever deployed an app with no defects? How'd you like to deploy an app with 9% of the defects you expect? That's huge. So what happens is the time ends up being shorter because you don't spend that time at the end thrashing, fixing defects. And let's be honest with ourselves. We've all been in that pre-release cycle where we're trying to get those defects out the door. You're struggling. You have 8 priority ones lined up. People are pushing, are you done, are you done, are you done? Are you honestly doing your best work in that time? No, nobody is, because you're rushed, you're hurrying, you're trying to get the thing out the door. By lowering those number of defects, not only do you create a higher quality product, you end up getting done faster because you don't have that end of cycle thrash. So that takes care of the time. So when you're talking to your boss, remember to speak time, speak money, and remember this data. Now there's one more group I want to talk about, and that's QA people. Now when you come in, and I see some people scowling, when you come in to talk about automated testing, this is what you look like to them. You're there to terminate them, and you need to make them understand that that is not true, okay? I love QA people because at the end of the day, for all the automation we have, somebody somewhere still has to put a pair of eyes on this thing. A human being still has to verify that it does what it's supposed to do. There are certain things we just can't automate. Not going to happen. And I don't want my QA people spending their time, frankly, wasting their time on things that should be checked by automated tests. I want them fixing the things I can't automate. I want them focusing on the things that they have to look at. So this isn't by any means a means of getting rid of marginalizing QA people. It's a means of freeing up their time to do the things that only they can do. QA people are great. You have to have them. You need them. If you don't believe me, go get rid of all you QA people. See how your next release goes. I'm guessing you're going to spend a lot of late nights at the office. So just make it clear to QA people, because they're going to see this as a threat. Make it clear this is not a threat. This is just another tool for them to help them do their job better by freeing them up for more time. So some next actions, go out and find some of these frameworks and play with them and look at them. Give them a shot. Let me know what you think. I did write a book on TDD. It makes a great Mother's Day gift. So go buy like a dozen copies. Your mom will love it. If nothing else, if she has a short table leg, you can use it for that. Hell, you buy it. I don't care what you use it for. All my contact information is up there, my website, GitHub. I'll put this up on GitHub this weekend so you guys can download it if you want. Twitter is up there as well. I'm pretty active on Twitter. I do have a podcast with called Hallway Conversations. I don't know if you guys know Phil Japixi. He and I do it with a couple other guys, Lee Brandt and Steve Bolin. It's on iTunes, and I guess if you're using Xbox Music, it's on there too, for the guy who's using it in the back probably. Are there any questions? Yes. Do I know if there's a similar tool to Visual Studio for Eclipse? Do you know if there is one, Jim?
Yes. Cucumber Dash Eclipse.
So there was a pause. I thought you were just going to say yes and then just let it go. That would have been hysterical, by the way. So there you go. Anyone else? Bueller. All right, well, thanks, guys. Oh, shoot.